Hello dear students, this is Dr. Saurabh Sir's classes. Our contact number is 98367930076. Again, I am repeating the number, which is 98367930076, and our email ID is saurabhsirclasses@gmail.com. Please feel free to contact via this contact details so we can arrange our online sessions or one-to-one sessions, online lecture series, and our you can join our regular batches, so that will be beneficial for your preparations, like for the peak examinations like TIF, RGS, CSIR, NET, NBHM, ISI, CMI, etc. So please feel free to call on this number or drop an email in this email ID. So now we are going to solve a true false question that is appeared in our TIFRGS 2025 question. So the question is telling us that let M be a, that means there is a statement, so we have to find the logic for its truth or it's a false. Okay, so let our M be a positive integer and Sm be the symmetric group on M letters. Let n be a positive integer such that for every group G of order n there exists an injective group homomorphism G from G to Sm, then our M is greater than equals to n. Okay, so we are going to use the Cayley's theorem here. So I think you know the theorem. Cayley's theorem. That is, Cayley's theorem states that every group G of order n, G of order n is isomorphic to a subgroup of symmetric group Sn. Yeah, Sn. Okay. So there exists an injective group homomorphism from G to Sn. Thus, our M equals to n is sufficient for the condition to hold. Now the key observation is the condition is in the problem is weaker than Cayley's theorem. That the problem only requires that there exists an injective group homomorphism from G to Sm for every group of G order n, not necessarily M is equals to n. So we are going to give a counter example for that. So to disprove this theorem, this statement, our which is gave us M is greater than equals to n, so we can construct a scenario where our M is less than n and the condition still holds. Okay, so now let us consider our n be 4. Any group of order 4 be like as the cyclic group, which is my, we can say that Z4, and the another group is Klein 4 group V4, which is isomorphic to Z2 cross Z2. Okay, so both of these groups can be embedded in S3. We'll know that the symmetric group on 3 letters, despite our M is equals to 3 and our less than our n equals to 4. We know that. So our C4 can be embedded as a C4, that means our Z4 can be embedded as a cyclic group subgroup of S3, and Z2 cross Z2 can also be embedded as a subgroup of S3. Thus our M equals to 3 is sufficient for the condition to hold even though our M is less than n. Okay, so the final conclusion of the statement is the statement M greater than equals to n is false because it is possible for M less than n while still satisfying the condition that every group of G of order n can be embedded in Sm. Okay, so this statement is false. Yeah. So again, I am telling that please feel free to call on this number or drop an email on this email ID so you can enjoy the services of Dr. Saurabh Sir's classes. Thank you guys.